All right, now we want to implement paging. So first we go to vehicle query class. Here I'm going to add two new properties, page and page size. And of course we could use byte here, but it doesn't really make much of a difference. Now we should also add these properties in our resource object. So vehicle query resource. Paste them here. And finally, we go back to our repository, vehicle repository, to implement the actual paging logic. So here, after we sort the data, we're going to implement paging. So we set query to query. Now we're going to use link, skip. And here we need to do some basic calculations. So query object that page minus 1 times query object that page size. So we skip all the records in the previous page if it exists, and then take a few records based on query object that page size. Now link provider is able to translate this into efficient SQL statements. So here paging is done in SQL Server, not in memory. Now before going any further, I want to point out that this logic here is not coupled to the concept of vehicles. It's highly reusable, and chances are we may need it in the future in other repositories. I don't want to repeat this calculation every time. So we can refactor this and implement it as an extension method on iQueryable. So let's go to iQueryable extensions. Here I'm going to add another method, public static iQueryable of t, and call this method apply paging. This is a generic method, and the first parameter is this iQueryable of t, and we call it query. Now, as the second parameter, we can use iQuery object interface that we defined earlier. So query object. Now we go back to our repository, copy this code into this new method. And here we simply return this new query. Now our query object doesn't have these properties, page and page size, so we need to update it. Let's go to iQuery object. Here I'm going to add page and page size. Now back in iQueryable extensions, we don't have any compilation error here. Beautiful. So our extension method is ready. Next, we're going to go back to our repository and simplify this line with apply paging and simply pass this query object here. It's much better, isn't it? And finally, let's test it. I'm going to set page to 1 and page size to 3. So here the first vehicle we get, its ID is 1. If I change this page parameter to 2, now the first vehicle we get, its ID is 5. Beautiful. So the happy path is working. Now let's explore the edge cases. What if I set page size to 0? We get a SQL exception. So we shouldn't accept page size less than or equal to 0. Now back in iQueryable extensions, we can solve this problem in a defensive way by throwing exceptions, or we can be a little bit more forgiving. So instead of throwing exceptions, we can set default values. So if query object that page size is less than or equal to 0, we want to correct it. Now here we can set query object that page size to 10. Let's try it again. Okay, beautiful. Now what if we pass a really large page size, like 200, more than the records we have in the database? Now here we get an empty array because we're on the second page. And if we have 200 records on each page, of course, we're not going to see anything here. So let's change the page number to 1. Okay, so here we get all the records. Now, what if we don't pass a value for page size? Still good. What if we exclude this parameter? Still good. Now let's try the edge cases with the page number. So page 0, again, we got a SQL exception. So the page number cannot be less than or equal to 0. So similarly, we're going to check for the page number. If query object that page is less than or equal to 0, set it to 1. And test it one more time. Beautiful. Now, what if we exclude this value? Still good. If we exclude the parameter, still good. If we add a page that is really large, well, if we go to page 1000, there is nothing there. So our API is stable. Next, we're going to add paging on the client.